Hello students, in this video we'll see an example of using a geometric random variable. Let's flip a fair coin until we land on heads. Let's find n so that the probability that the first head occurs at time less than or equal to n is at least 99% or 99 over 100. So we'll do some simple examples first. The probability that the first head occurs at time 1 will be 1/2. The probability that the first head occurs at time 2 will be 1/2 for the tails that came on the first event, and then 1/2 for the heads at the second event. And similarly, we can see that the probability that the first head occurs at time k will be, you will have to have k minus 1 tails and then 1 head. So we can recast our problem. Our problem now is to find the probability that the first head occurs at time less than or equal to n. And that will be the sum of all these probabilities. That will be 1/2. That's the probability that it occurs at time 1, or 1/2 times 1/2, the probability it occurs at time 2, or 1/2 squared 1/2, the probability occurs at time 3, all the way up to when this occurs at time n will be 1/2 to the n minus 1 times 1/2. And we have a geometric progression over here, so we can pull out a 1/2. So this will be 1/2, and then I'll have a 1 plus 1/2 plus all the way up to 1/2 to the power n minus 1. Now at this point we should remember our geometric sum formula. Our geometric sum formula is 1 plus r plus r to the n is 1 minus r to the n plus 1 over 1 minus r. So we can use this formula over here. Doing this, we'll have a, that's just our side note, 1/2. And now my n here is n minus 1, so I'm going to have a 1 minus 1/2 to the n over 1 minus 1/2. The denominator is equal to 1/2, so this will cancel with this. And so we'll just have 1 minus 1 over 2 to the power n. And we want this probability to be bigger than or equal to 99 over 100. So what we want from our problem is I want this to be bigger than 99 over 100. So we can rearrange this. I can put this 99 over 100 over here. So I'll have 1 over 100 bigger than or equal to 1/2 to the n. I'll take the natural log of both sides. So the natural log of 1 over 100 is bigger than or equal to the natural log of 1/2 to the n. And so that n can come out, which is n natural log of 1/2. And now the natural log of 1/2 is a negative number. So when I divide by this, I'll have to change the sense of the inequality. So that will tell me that n is bigger than or equal to the natural log of 1 over 100 over the natural log of 1/2. which we can simplify a little bit as negative the natural log of 100 over negative the natural log of 2. And by the change of base formula, we see that if n is bigger than or equal to the log base 2 of 100, then this will work. And so we can clearly see that, for example, the log base 2 of 100 is between 64 and 128, which is between 6 and 7. So we see that if n is equal to 6, this will not quite work, but if n is equal to 7, that will work. So it looks like if we wait at least 7 times, the probability that the first head occurs at time less than or equal to 7 will be at least 99%. Thank you very much.